Okay, so today we're diving into a really cool breakthrough that's teaching AI to do way more than just see the world. It's actually giving it a voice to describe everything it sees, right down to the tiniest pixel.
So take a look at this. Any AI can tell you there are two boats here, right? But what if it could go deeper? What if it could describe the ripples on the water, the texture of that wooden pier, even the individual seats on the boats? That's the huge, complex challenge we're going to unpack. This gets at a huge issue in AI, something folks call the silent observer problem. We built these incredibly powerful AI vision models that can see every little detail, but they're basically mute. Seriously, it's like having an art historian who can see every single brushstroke in a Monet, but has absolutely no words to tell you about it. That's the core of the problem.
So you might be wondering, how do these AIs get so good at seeing in the first place? Well, a lot of them, like the famous DINOv2 model, use a really cool technique called Self-Supervised Learning, or SSL. Basically, they teach themselves by just looking at billions of unlabeled images. They just start to figure out the patterns and the structure of the world all on their own.
And what you're seeing here? This is the result. It's a rich, super detailed internal map that the model creates in its mind. It's not just spotting objects, it's understanding textures, shapes, how things relate to each other. It's really capturing the essence of the scene.
But here's the kicker. All of this amazing, brilliant visual understanding is totally locked away. It has zero connection to language. And that really limits how useful it can be for anything that requires, describing what it's seeing.
Now, of course, researchers have been trying to solve this for a while. They've been working hard to build a bridge between these powerful vision models and language. But as it turns out, building a good bridge is incredibly difficult.
So there have been two main strategies. On one hand, you've got the train-it-all clip method. That's where vision and text models learn everything together from scratch. It's really powerful, but it costs an insane amount of computing power. On the other hand, you have the freeze and train lit method. Here, you take a pre-trained expert like DINOv2, you freeze it, and you just train a text model to understand it. It's way cheaper, but there's a catch.
And the paper for this research really nails that catch perfectly. They found that when you try that cheaper lit method, the performance on tasks that need you to see all the tiny details, well, it just wasn't good enough. The bridge they built was just too weak.
And this is where our hero, a new method called dino.txt, comes into the picture. The researchers behind it didn't just try to build the same old wobbly bridge, they came up with a whole new, much smarter recipe for making that connection.
Their recipe has 3 key ingredients that make all the difference in the world. First, they create a richer image signal. Second, they add a small adapter to the vision model. And third, they get way smarter about the data they use. Let's break each of those down.
Okay, first up, the image signal. Think about it like this. Most other methods just give the language model a quick summary of the image. The big picture. But dino.txt is way more clever. It gives it that big picture summary, but it also gives it a summary of all the tiny individual details. This gives the text model so much more to work with, a much richer understanding of the scene. Second, adapting the vision. Remember how that powerful DINOv2 model is frozen and rigid? Well, to help it communicate better, they added 2 small trainable layers right on top. You can think of these little vision blocks as a flexible translator, helping that expert vision model speak the same language as the brand new text model. And that brings us to the third, and maybe the most crucial ingredient. It's not just about having tons of data, it's about having the right data. And this is where dino.txt really shines by working smarter, not harder. See, the problem with just scraping the whole internet for data is that you get a lot of junk. Captions are generic, datasets get really unbalanced. So previous methods try to fix this by just filtering the text. But dino.txt takes it a step further. It balances both the text captions and the visual concepts in the images. This creates a much higher quality, balanced diet for the AI to train on.
So what's the payoff for this smarter recipe? Well, the difference in efficiency is just staggering. Look at this chart. Dino.txt got these incredible results using just a tiny fraction of the computational power. And that's a huge deal. It means more people, more labs can actually build on this work, speeding up progress for everybody.
And get this, all that efficiency didn't come at the cost of performance, not at all. Dino.txt hit an incredible 81.4% accuracy on the super tough ImageNet benchmark without ever seeing an example beforehand. It's faster, it's cheaper, and it's better.
But you know, numbers only tell half the story. Let's actually see what this new model can do, because the results are genuinely stunning.
Okay, check this out. In a pretty complex safari park scene, it doesn't just see a giraffe. It can perfectly segment the animal itself, the car, the people in it, the railing, and the road, all from simple text prompts.
And look at the level of detail here. This is amazing. It's not just finding bread. You give it the prompt pesto bruschetta, and it correctly isolates those specific pieces. It understands these fine-grained, really specific concepts.
And this isn't just for exotic scenes. Here, in a normal living room, it does just as well. It correctly identifies the sofa, the pillows on it, the coffee table, and even the plant sitting on the table. It just proves how incredibly versatile it is.
And look, this isn't just us saying, wow, that looks cool. The data backs this up in a huge way. On a key benchmark for this kind of task, dino.txt scores a 20.6. The next best model, it's at 9.1. That is more than double the performance. It's not just a little bit better, it's a massive leap forward.
Okay, so let's just zoom out for a second and look at the bigger picture. What does a breakthrough like this actually mean for the future of AI and computer vision?
The real takeaway here is that dino.txt is more than just one cool model. It's a recipe. It's a highly efficient and effective blueprint for giving these super perceptive seeing AIs the speaking ability they've been missing all this time, finally unlocking their true potential.
And this leaves us with a really fascinating thought. For so many years, the biggest challenge was just getting AI to see what's in an image. But now that it can see and describe the world with pixel-perfect precision, the question isn't, can it see anymore? It's, what are we going to ask it to see next?